Today we take you along on a long journey that is the birth of a lens, that is from the creation to the final product, everything about how a lens is done. And this is a vacuum coating machine where the coatings are applied to the lenses. Let me show you.
Every time you put a lens on your camera, you use a piece of equipment that is full of ingenuity, craftsmanship, technology, and a little bit of alchemy. In this episode, we explore all the steps in the production of a lens. The cutting, grinding, and polishing of lens elements, following the process of making glass step by step more transparent. We show you how lenses are coated and how elements are cemented into doublets and triplets, how housings and mechanics are machined, the markings are engraved, how electronics are implemented, and how continuous testing leads to pristine products. If you're a photographer or a filmmaker that loves the tech behind your gear, all this will be super interesting for you. And we will have a lot of fun with our trip in general, giving you some deep insights into Chinese lifestyle. So follow us to China and experience the birth of a lens. I just love to nerd out about technology behind filmmaking, and lenses have a very special place in my heart. There's just something magical about optics. So I was very happy when Laowa dropped us a line and invited us to have a look at their production in China, especially as Laowa is famous for lenses that are particularly interesting for videography and cinematography. If you have been around this channel, you have seen a lot of Laowa lenses throughout the years. Ultra-wide macro lenses, probe lenses in many shapes and forms, anamorphic zoom lenses, and even microscope zooms. Laowa had a major impact on product videography and is famous for creating whole lens classes that just didn't exist before, or making special lenses affordable enough to bring them into the reach of regular filmmakers. Laowa has two manufacturing locations in China. The main factory in Hefei and an additional smaller factory in Shanghai where probe and cine lenses are made. We visited both locations and spent a week documenting every step in the process, from the inception of an idea to design and production. And of course we will cover all the juicy details with the grinding and the polishing of the optics, coating, calibration, mechanics and so on. It was quite an experience and we're excited to take you along to show you what we learned. You might assume that lens development is done by thousands of people, but in reality, it comes down to just a handful of people that are the source of everything. So we hopped on a plane and flew to Hefei in China to meet the man behind the curtain. Dae-Yong Lee is the founder of Laowa and the mind behind every of its lenses. He also developed countless lenses for European and Japanese brands. A real titan of optical design.
Hi.
Hey!
Nice to see you. Hi.
And also a really nice guy. He will show us around, give us a bit of input about Laowa, the industry and where it's going. If the sky is the limit, Mr. Lee has already been there. His optical designs made it into space. This is a model of the Chinese space station. We have 3 of our Cine lenses currently deployed on it. Each of these 3 lenses has a specific role and purpose. The wide-angle lens is used to capture the environment inside the cabin and panoramic views of the entire Earth through the window. The other 2 lenses are primarily used for portrait photography, capturing the astronaut's daily life and work. The telephoto macro lens captures details of experiments, including close-ups of small objects during experiments. But it's also used to capture more detailed views of Earth through the window. We are proud that these 3 lenses are the only Chinese lenses inside the space station. They are true one-of-a-kind lenses in the film industry.
Looking at the history of Laowa and what you did over the years with this company, Where did you come from? What is your origin story?
哦，我毕业之后呢，首先
After I graduated in optics, I worked in China for 3 to 5 years. Later, I had a chance to start working for a large company in Japan. I was involved in optical design for several major international brands. As those brands were backed by venture capital, they were risk-averse and hesitated to experiment with more exotic designs. But those were exactly the lenses I wanted to develop. To bring them to life, I knew I would have to leave those large teams and companies. The seed to start my own business was planted in my head. It is now over a decade ago that I took that big step and founded Laowa.
跳出来之后，自己创立了老蛙这个品牌。
Okay.
哎，
These are the lenses I developed since starting Laowa. These are the photography lenses, and those over there are the Cine lenses.
Some old faces that are known. I shot with many of these lenses over the years, especially, of course, the Cine lenses in all our episodes. And this one, I think, at least for me, this was the one lens that put Laowa on the map. I didn't know Laowa before this one. I'm a filmmaker, not a photographer. And this one is really special for me because, well, there were probe lenses before this one, but they were huge and heavy. And this made it so affordable that you made this possible for the normal street guy to shoot it. And even professionals like me with the Marmalade, we shoot a lot on motion control robots, where we really shoot it on speed through the room. And if it's so light and so compact, that has amazing advantages. Not at least that they break a lot, and then it's in the budget, you know. So thank you so much for it.
Thank you.
So, as this is, as this episode is called "The Birth of the Lens," where does the inspiration for a lens really come from for you? Where's the spark?
我的灵感其实主要是来自于
My inspiration actually comes mainly from in-depth conversation with users. I talk to photographers online to find out what they need, and then I use my expertise and technology to make it happen. Once I develop a solution, it eventually leads to all sorts of specialized lenses. Here are some of the new lenses we are about to release. We have a whole range of special lenses for different applications, such as broadcasting, stereoscopic imaging, anamorphic and macro photography. These are the ultra-macro zooms. The original macro zoom couldn't maintain focus. Whenever the zoom factor was changed, it required refocusing. The new ultra-macro zooms I've developed are parfocal, so once the initial focus is set, objects remain in focus. The optical design is very innovative and industry first.
This is very interesting because we just launched the test episode of the Cine versions of these specific lenses, and there's something else, really like covering the zone between macro and micro, so that is quite interesting. Check it out. Now, this is a big boy. Oh, 25 to 600, and it's heavy too. So
This is a Super 35 broadcast lens, a super zoom with 25 to 600 millimeter
Okay.
focal length range.
that is amazing. And what is this one?
This is a 3D zoom lens. It can zoom and project two images on a single sensor. These images can be used to create a stereoscopic image using an ordinary camera.
Interesting. And oh, the Proteus, like old friends, right?
This is the new full-frame version of the Proteus Anamorphic series. A new key feature is adjustable bokeh. The cinematographer can choose how sharp the bokeh is by
that's
turning
cool.
this ring.
Well, besides those lenses that we have seen now, these have been announced. What does the future hold for Laowa? Can you tell us about lenses that we haven't seen yet?
As you may guess, we have many lenses in development, but we can't reveal too much at this point.
Maybe one more question, and I'm honestly interested if there was no market restriction, if there was no money problems or whatever, is there something you would love to create like your Mount Everest? What would be the lens to build?
I would love to develop a super macro zoom lens that is able to bridge the macro and the micro worlds, say with a 50x or 100x magnification. You could start with a wide-angle shot and then zoom further and further into the image, gradually bringing the macro and micro world into focus. For example, you could film a talent at a half-body shot, and then by slowly zooming in, you could capture the fine details of the facial hair and nose lines.
Wow. Well, if you ever build it, I'll buy it.
With this background and outlook, where do we begin our journey of lens production? After Mr. Lee came up with the idea and an optical design for lens, the baton is passed to the R&D team, and we are heading right there now. The research and development team takes the optical design of Mr. Lee and turns them into a working lens. Besides the optics, this will also include the mechanics, iris, servo motors and electronics, everything that goes into a prototype. While most of the work happens on screen in CAD software, the engineers and designers also build their own parts and assemble prototype lenses to test if mechanics and the electronics work as expected. That might include light soldering and routing of cables. You definitely need a steady hand for this work. The result of the R&D process is a fully working prototype that can be tested under different working conditions and, of course, for its image quality. Like this cross-section shows, there's a staggering amount of parts that are combined with very high precision to keep the lens elements in the narrow window of tolerances required for a pristine image. By the way, these are the guts of a Proteus 2X Anamorphic Cine lens, the brand new full-frame version. Here is an assembled pre-production lens to give you an idea about the size and where the elements sit. For comparison, these are the guts of the Proteus 2 Anamorphic Zoom. In both cases, the anamorphic elements are much bigger than I expected them to be. One question I always had was what focusing techniques both of these lenses use, and I got the answer. So here's something for the hardcore anamorphic geeks. It is not a diopter design, but the spherical focusing group is moved in front of the anamorphic block, allowing the lenses to be lighter and more compact, which made the Proteus zooms possible in the first place. I'm amazed how open Laowa was with explaining the inner workings and what we are allowed to show you here. One doesn't seem to be afraid of copycats. On this desk, we get a look inside the giant 20-800 broadcast zoom Mr. Lee showed us in the showroom. We are now going to explore the processes that create a lens element in such a design. The manufacturing of the lens involves cutting, sawing, grinding and polishing. Therefore, it can be a little messy and no clean room is required at this stage. It all starts with the substrate itself, a block of glass. This glass contains additives designed to modify certain optical or mechanical properties of the glass: refractive index, dispersion, transmittance, thermal expansion or other parameters. The glass that we see here being cut would be used for square-shaped elements like prisms. It is very important for this step that all sides of the raw material are fully cut to reach the final dimensions. Afterwards, all sides are intentionally grounded matte, so the polishing process removes material uniformly. This machine roughens the surface of the glass block. For spherical lenses, workpieces like these are used. The glass supplier delivers these already cut to the desired diameter and thickness. This workpiece looks opaque, but it's not. All sides are matted as described in the previous example, just by the supplier directly. This process is called curve generation. It removes bulk material rapidly from the raw optical blank. This locks in the specific curvature, concave or convex, to create the target focal length. The basic radius is established here, while later processes refine it to optical tolerance. After the washing, the glass is further processed by grinding in 2 stages. The first stage, the rough grinding, uses a harder diamond abrasive to control the glass's thickness and spherical curvature, so the concave or convex shape. The stage effectively removes material but leaves the surface rough. This is a clay operating station, which is not for processing the glass itself, but it fine-tunes the grinding tools for curvature parameters and sharpens them. I was actually surprised to find that the sharpening process is done manually by a skilled craftsman. Grinding tools come in all sizes and shapes, just like the lenses they're built to create. The second stage, the fine grinding, uses a softer diamond abrasive to refine the surface, remove imperfections and improve smoothness and brightness. The goal is to make the glass semi-transparent, preparing it for the subsequent polishing stage. Here you see our convex workpiece after grinding. The next procedure is polishing. Polishing happens by a multi-stage automated process transitioning the glass from opaque to transparent. Polishing machines are designed to accurately machine multiple geometric features of a workpiece. The core of this process lies in precise sequential control, breaking down complex geometric machining tasks into a series of independent, controllable, linear actions to ensure the dimensional accuracy and consistency of the final product. Up to 6 different procedures are utilized to shape the outer diameter, the curvature and the chamfer, a transitional angled edge between 2 intersecting surfaces. After polishing, a lens has its final dimensions and shape. Now, convex and concave lenses fit perfectly into each other to form a doublet inside a group. Before they can be glued together, the lenses still need a coating. So we'll come back to the cementing of doublets and triplets in a couple of minutes. What about aspherical lenses? Traditional grinding and polishing is not efficient for that task and glass molding is used. In that technique, glass is heated to the transition temperature, that is, right before glass gets fluid and then pressed into the desired form. We would have loved to show you that, but aspherical lenses are produced by an external supplier. Same is true for anamorphic lenses. The facility has the equipment to produce anamorphic lenses, this one is one of them, but it is more efficient to leave that to a third party. To ensure that all preceding processes meet quality standards and that the lens has the desired specification, this machine validates the curvature. This is called the Ronchi test. The straight lines indicate correct curvature. If the lines are not straight, the part is rejected and sent back to the polishing stage for rework, ensuring that process failures are caught and rectified immediately rather than propagate downstream. This machine checks how precise the center axis of a lens is. A laser is projected through the lens while it's spinning. The wiggle of the cross on the monitor shows how much the laser is offset by the lens. The smaller the wiggle is, the higher the precision. Lenses are cleaned and checked visually for scratches and other flaws. This machine tests the dimensions of the diameter. Only a very high precision allows a lens to fit perfectly in the design group elements. Has a lens passed quality control, it is handed down to the next stage of the production.
I never had the chance to actually see how coatings are applied to lenses, and this is the machine that actually does it. Come along, I'll show you.
Before we go through the process, let's take one step back. Why do we need coatings in the first place? Whenever a ray of light moves from one medium to another, some portion of that light is reflected from the surface. This happens with the surface of a lens. If reflection increases, the transmission gets reduced. The image gets darker. If reflections are suppressed, the image gets brighter. A lens can reflect as much as 8% of the light, that is, per lens element. Especially in complex designs with many lens elements, this means a significant loss in light transmission. In this example with a coated lens and one where I removed the coatings, you can perfectly see that the uncoated lens appears more like a mirror than a transparent medium. Lens coating were first developed by Zeiss in Germany, and military applications drove the rapid adoption during World War II, for example in the optics of flak cannons. Modern multi-coatings are very effective in suppressing reflections and making a lens brighter, while also reducing artifacts like ghosting and veiling flares. Especially in cinematography, flares are used on purpose to invoke feelings, and here it becomes an, let's say, alchemistic art to create a blend of coatings that result in the right mix of flare colors, shapes and textures. The coating process starts by removing any pollutant in a clean room. It would be detrimental if pollutants get trapped between the lens surface and the coating. Lenses are then placed in a heat-resistant tray and checked one last time. The coatings are applied with a vacuum deposition evaporation coating machine. That rolls off the tongue, but the name is also very descriptive. Chemicals are evaporated inside a vacuum chamber to deposit a thin layer extremely evenly on the lens's surfaces. During processing, the wheel rotates, making the coating more even. Different racks can hold different sizes of lenses. A revolving magazine is then loaded with the different chemicals for each coating. These are usually metal oxides like titanium oxide. The technician starts the process and the air is pumped out of the chamber, creating a vacuum. Now, the first chemical in the revolver is heated by an electron beam to over 2500 degrees Celsius, causing it to vaporize. The vapor rises and condenses onto the spinning lenses. This process is highly precise and measured in nanometers. When the first layer has settled, the remaining vapor is pumped out of the machine. The next chemical is vaporized, allowing the whole coating process to be finished in one go. Different chemicals glow in different colors and in different brightness. It's actually quite beautiful.
Of course, we faked the one with the light in the beginning, but not because it's not that bright. It actually is, like you can see here. This is the actual burning process of the chemicals that do the coatings. We just couldn't do it because if you really look into it, it's so bright that it could damage your eyes. So that's why we faked it.
After the process is finished, air is pumped back into the machine so the door can be opened and the lens tray is moved to the next stage where quality control checks the results. Here we see how a lens is inked, meaning that the edges are blackened. When integrating lenses into a multi-element system, stray light can become a problem. Blackening the edges of the lenses is a method to reduce the stray light. This station combines concave and convex lenses into doublets and triplets. Multi-lens configurations like these are designed to improve image quality by fixing optical errors like chromatic aberrations. Cementing of the lenses is done with very thin optical neutral glue. Precise positioning of both lenses during the cementing is required. Wiggling the lens will remove microscopic bubbles from the glue. Very similar to the machine that tested the center axis of the individual lenses, this machine tests the combined center axis of the lenses in the doublet. When a lens has passed all quality control stages, it is packed and delivered to the assembly unit. But before we go into the assembly, we are going to have a look at the department that produces the housings and the mechanics of the lenses. And that starts with cutting and milling aluminum workpieces with hundreds of tools inside of CNC machines. When the machine part have passed quality control, they are shipped to a specialized company that does the anodizing to increase the durability and to give a lens housing its color. When the housing comes back from that process, the engravings are applied using a high-power laser. The engraved markings are then painted in and the housing is ready for assembly. If the lens has autofocus or other features that require electronic parts, it requires the necessary motherboard, servos, wiring, and so on. We are now going to have a quick look on how that works. I'm just going to ask you for one quick favor. Please like this video and leave a comment. This triggers the YouTube algorithm to share this episode with more people, and this means we can continue our mission to create great content for filmmakers. No clickbait, no slop, just real edutainment that is made for you. Besides, we usually answer each and every comment, so if you have any questions, shoot. And while we're at it, why don't you subscribe if you haven't done that already? We have a lot of more interesting things for you in production, so don't miss it. Thanks a lot for listening and your support. Now let's get back to the show. The PCBs of the motherboard come in a wafer, and this process applies soldering paste using a kind of stencil. There's something weirdly satisfying about how perfectly this works on such a tiny scale. Next step is a SMT pick and place machine, something like a loom for electronics. A robot head uses air suction to grab a chip from a tape and drops the chip onto the exact spot of the motherboard. The wafer is then placed in a reflow machine, an oven that's heating the soldering paste until it melts, forming strong, reliable electric connections. Many parts in the electric department have to be assembled and wired by hand. That includes manual soldering. That black trumpet there sucks away the fumes from the soldering. Connections and servos are tested by connecting the motherboard to a camera and going through the range of the device. Now that the optics, the housing and the electronics are ready, the lenses can be assembled. From here, workers have to wear a bunny suit as the assembly happens inside a clean room, for obvious reasons. We are no exception, so I hopped into a bunny suit myself. You enter the clean room through an airlock in which you get an air shower. All parts that go in and out of the clean room go through their own airlock that is called a pass-through. There are many stations here that share the various drops that go into the assembly. Let's take it as a moment of zen. Testing is an integral component of the assembly process. After the connectors are assembled, function is tested immediately. But even the incoming lens elements are again tested for their accuracy. Lens groups are rechecked for being perfectly centered. And here we see a negative example that will be sent back to the optics department. When all groups are assembled, the lenses go on a projector. Here, a worker can calibrate the centricity of the elements with screws. The results are verified on cameras that lets the tester zoom in and scan the field of view, edge to edge. This is an ultra-macro zoom lens, and the test verifies if the lens is sharp and absolutely parfocal. This machine is a resolution board and sensor feedback system. Below the lens is a beam of light, and above it there is a cross, which is called a resolution board. The image of that cross is received by these 9 sensors after passing through the lens, giving precise data about the performance of the lens and if it matches the specifications. When a lens has passed all tests, it is packed in a box, sealed, and sent out to its new owner to shoot something amazing. We are not quite done yet. We will continue in the Shanghai factory that manufactures the probe and Cine lenses. And before we take you with us on a bullet train, it is a good moment to share some of our impressions from the trip. The media division is surely no travel channel, so if you're not interested in that, just skip to the next chapter. But filmmakers often have to travel way beyond their comfort zones, and traveling in China is always an adventure. This trip was nothing short of that. Enter the dragon, China. And even Smaug couldn't be more mysterious. This country is just so full of contrasts, neon jungles, high-tech toys, historical sites, and things like this coexist in a blend that is intriguing. We had one day to do a bit of the usual tourist stuff.
How do you feel?
But don't worry, we will not bore you with more than these impressions, although it's absolutely fun to come to cities like Shanghai as a tourist. With a metro population of around 30 million, it dwarfs whole countries and is very vibrant. It feels like San Francisco on steroids and other stuff. Hefei is very different and probably much closer to what one would consider normal life in China. Smaller, but still packing 6 million people. Caucasians are quite common in the touristic parts of Shanghai, but in more industrial cities like Hefei, it is very different.
The airport, I haven't seen a single Caucasian.
Hello.
Hello. Evening, good evening, good evening.
Looks like he hasn't seen any either.
Something you have to be aware of in China.
Be aware that almost nobody speaks English in China, unless they are from Hong Kong, not even in airports. Translators on your phone make everything possible, and nobody uses cash. Everybody pays everything using apps like WeChat or Alipay.
It's a rice dispenser. Have you ever seen something like that?
Food is generally very good, but it might challenge Westerners. A whole new world of tastes await you.
Morty, chicken foot. You gonna try that one? Are you gonna try it? He does it. Amazing. And how does it taste?
I mean, the taste is not too bad.
Does it taste like chicken?
It does taste like chicken.
Wow,
but the
that's surprising.
consistency is.
Imagining how much shit they walk in, it's surprising that they taste like chicken. How exactly do you use the sticks?
So you have to break it in the middle.
Abalone, and it's a sea snail.
Like
So-
Gary from SpongeBob.
Yeah. Gary. Meow.
When it rings on your door, it might be a robot delivering your dinner. And your dinner might have a face and a beak. This fish is a Shanghai specialty that might be best described as a culinary version of a blood eagle.
Delicious. This is good.
One of the quickest ways to learn something about the daily life in a foreign country is to visit a supermarket to see what's in store, what people are buying, and what things cost. So let's do just that.
It's actually pretty cool.
If you hear the prices, you have to take into account that wages are much lower in China, and so are the rents. But we are also in a very exclusive supermarket, so the truth is somewhere in the middle.
Potato. Oh, it's mango. It's mango. This is like 500 grams, so this would be $1. Now, $1.50. Now look at this. This is a passion fruit beer, and it's exactly in the size I like it. It's $1 for a liter. That is, yeah, I think $2.50 or something like that. I think generally the prices compared to Europe is about a third and a fifth maybe to USA at the moment.
What, are these like? Are there any special flavors here?
Actually, do you know this one Fanta?
Fanta.
Fanta
Yeah, yeah.
is German.
I know, but we have a Chinese version.
Oh, really? Does it taste different?
Arctic Ocean. I don't
You know
think
when Fanta was who developed the Fanta? The Nazis. And it's a true, it is actually a true story. Look it up.
I didn't even know that.
I actually like this. This is a really nice supermarket and extremely cool stuff that you don't find in Europe anywhere.
What is it?
I don't know. No, that's mean.
A lot of them don't look too alive.
Oh, toads.
Well, hello there.
This is not a pet store, remember that one. It is, it's a crayfish. Delicious, I can tell you that much.
Eel.
I think she's cute. White rabbit. I hope there's no rabbit in that ice cream.
You never know.
You never
Never know
know.
for sure.
They're saying that you two are handsome. They are saying that you two are handsome. They are telling me they think you two are handsome.
Oh,
Oh.
thank you. She is. Oh, they do it Borat style. We think he's handsome. The other one not so much, but he is. Let's try the
Oh, Jesus.
Chinese Fanta, the taste of the world.
Well, cheers.
Ganbai.
Gone by.
It's not bad whatsoever, but it
Tastes like
doesn't
Fanta.
taste like Fanta.
You want to try this one?
Yeah, okay.
I feel like mine tastes like Fanta.
It tastes like you now.
That's
This
different.
does.
Yeah.
Fanta, does. So, this is the Nazi Fanta.
Great.
Morty, you might think this is just another airport, but it's not. It's a
On a train.
train station. It's the main train station from.
Hefei.
Thank you for that. And we're gonna take that one to Shanghai right now. It's gonna take 40 minutes, so we have a little bit of time to hang around.
But it's gonna take 40 minutes to go to Shanghai. It's gonna take 40 minutes until we can board the bullet train.
No, it's gonna take 2.5 hours
Yeah.
to Shanghai. Look at this. That's a charging station in the seat in the waiting hall of a train station with different plugs for different phones. So Europe, America. Can your train station do that? The business model behind it is that you have to scan a code and then you have to describe to a Billy guy, that's like YouTube in China, and he gains a follower and pays for your charge. Just imagine that, like that's a new YouTube model. I think that's pretty awesome. I don't know who this is, but thanks for the charge. So when the bullet train comes, it goes so fast, it will just go, and it stands right there, and you will still see the motion blur because it's built in. Let's see. So we're on the bullet train and we're at 240 kilometers an hour. And Mr. Lee gave us as a gift like these wonderful lenses, this 10mm Dreamer wide angle lens. And first of all, they got you an E mount
That's
and me an
great.
L mount. I mean, that's very thoughtful because I'm a
Also-
Lumix shooter and here's
Autofocus and manual focus.
Manual focus. It's just perfect. So as we're on the fast train and we are like at whatever 240 kilometers an hour, we're gonna do who can unpack faster. Let's do it.
I got it.
I think that was pretty, but we need a finishing photo for that.
Yeah. What do we do with it now?
What are we gonna do with it? You look so small now.
And the world is so big.
Morty, you're so far away. Don't leave me behind. Just don't.
After a good night's sleep, we were off to the Laowa factory in Shanghai. The car that drove us here has a drone pad in the roof, so you can overlook traffic jams and the like. It can even start and land the drone while the car is moving. This gives us the opportunity to show you the facility. It is much smaller and more intimate than the one in Hefei.
How cool.
The showroom is also very different.
Test.
It is really designed for cinematographers with stories about lenses and how they are used, and of course you can test lenses right here and then.
One also film with Laowa 25 to 100 is a Wong Kar-wai
Oh yeah.
moving.
Oh, he used the or what did he use?
Yeah.
That looks like the
The
Yeah.
25.
原来就是说大家都很大嘛，所以我们就是没有控制器。
Oh, because this is his first cine zoom lens, and he saw all cine lenses are huge, right?
Yeah.
So he didn't think about like making it smaller. And when he attempted, that's the range camera, so their optical quality is like similar. It doesn't have like a huge form.
Okay. No. So this is the first time well, when it came out 6 years ago, I noticed the and I found it interesting. Of course, there was a lot of movement towards full frame in the last couple of years, but now with the Alexa 35, and so the is really a contender, and it's the first time I have it in my hand. It really feels solid and nice, just like an ingénieux that would cost like 4, 5, 10 times as much. It's quite nice, actually. And the range is really, really good, huh? 25 to 100, that's a set in one. So if the is not enough, there is a full frame version that has even more range. It's 25 to 180. It's been announced, but it's not for sale yet. I mean, that is a range, and it is quite a... Now, what's the price of this one?
15K.
15K.
Oh wow, okay.
哦，所以我们是一公斤，
Cool.
这个4公斤。
But we don't... Oh, yeah. Look at this beast. I mean, it's not marked. It's a prototype. We cannot show you the exact focal length, so don't look at this, but it's much longer. It's more than twice of the range that you saw before at a decent speed. Actually, f4.5, that's fast for a lens with this gigantic zoom factor. And it's, wow, I mean, that's what I call an entrance pupil, huh? Can you put it on the camera?
Let's put it on the FX3.
Yes. Our lens support is Kiva.
它有吧？它有，
Put it here.
那个可以。
Should work. I do it again. It's hard to keep it. I think we could do it as a reverse. That was decent. Jesus Christ. That's a zoom.
Inside the facility you have clean rooms, and like mentioned, the Cine lenses, especially the anamorphic lenses and the probe lenses, are assembled here. Of course, the process is quite similar to the photo lenses. What is different is the design philosophy, engineering standard and the quality control processes. Cine zooms have a parfocal design and maintain focus throughout the entire zoom range without refocusing. The frame's center point remains fixed during zooming, preventing shifts. Additional lens group correct the optical path, ensuring that the focal plane remains constant. This adds to their size and weight. And of course, suppression of the breathing effect. meaning that the frame size does not noticeably expand or contract when adjusting the focus. Due to these features, quality control requires 3 inspections. For anamorphic lenses, additional checks for specific optical characteristics like flares are performed. All this makes Cine lenses more expensive, even though they lack the servo motors and electronics from autofocus lenses. The housing and the mechanics are actually more expensive to produce than the optics themselves. The probe lens assembly process has been optimized, moving away from the traditional method inspired by endoscopes. Lenses are divided into independent adjustable groups. The advantages? Specific lens group can be rotated to optimize the optical path. The intervals between lens groups can be precisely adjusted, and if a particular lens group is found to be faulty, only that specific group needs to be replaced, rather than the entire assembly. Maybe you notice in some of the behind-the-scenes shots that we have a ranger zoom on the A-cam, and that we basically film the complete process of its own genesis. Cosmic. I do have to say that the Ranger did a great job in this documentary-style context, offering a very decent range, speed and close focus while remaining relatively compact and light. For our intro, we filmed the complete assembly of a Ranger zoom. Mr. Li used the time in Shanghai to work on his lens designs, and the discussions looked very interesting. So sad that I don't speak Mandarin and would have loved to be a fly on the wall. But it seemed to be a lot about fine-tuning. Talking about Cine lenses and tuning, there is always a bit of alchemy involved, and it has been popular to detune Cine lenses for a more individual look that might suit a certain narrative style. Morty used the opportunity and a team of optical engineers to explore detuning in the lab. He will post his own episode about DIY detuning on his channel Morty Films, so if you are into hands-on lens work, you should really check it out. I'll put a link in the corner and in the description once it's out. I'm here in the part of the facility that assembles the anamorphic lenses at Laowa, like the Proteus primes. And this is the brand new full frame anamorphic prime. It is just announced at Cine. It looks and it has exactly the same dimensions that the S35 version of this lens has. And it has a very cool new feature. You can actually change the sharpness of the bokeh on this one. You can adjust it with a ring on the fly, so it suits the project you do at each moment. Now we have the wonderful opportunity to look what goes inside here in terms of anamorphic elements and how they work together to create anamorphic magic. What elements are how assembled to watch each other, and we're going to do that right now. In the R&D section, I already mentioned that this is not a diopter design to focus. This is one of a new way to focus, and it means that a spherical group is in front of the anamorphic block. This allows the anamorphic elements to be a bit smaller, which makes the production cheaper, and it also makes the lens lighter. What you might know is that the anamorphic parts work a bit different than spherical elements, because they have to be adjusted towards each other very, very precisely. While a spherical lens has only to be centered through all the elements, these have to be very precisely centered, not only centered, but the rotation has to be correct too, and that in a very, very precise way. So there are 4 elements that go into an anamorphic lens, like the Proteus prime, maybe even 5 if you count
that the biggest part, this one, is a doublet already. If you look very carefully, you might be able to see that these are two lenses that are put together to a doublet. This is the first group with a doublet that goes into that lens, and you might be able to see the screw holes here. And these screw holes are there to make adjustments, because you can't really produce parts like this with a precision that would be good enough so you can just throw it in. So there's left a little space on purpose, and the screws will allow to adjust the lens. And I will now show you exactly how that is done. Of course, I will not do it. A pro from Laowa will show us.
The unit that is calibrated here is the Proteus Flex. The anamorphic elements are all combined into this unit that can be recalibrated or exchanged for different flare colors without having to send the complete lens in. Swapping the unit can be done by the users themselves, and the lens doesn't need to be recalibrated after the swap. Anamorphic lens calibration is a critical technical challenge in production. The process involves precisely adjusting two groups of cylindrical lenses which function optically like X and Y axes. Optimal image quality depends entirely on accurately locking their angles at a 90-degree intersection. Even minor angular deviation can lead to severe issues such as blurry centers, ghosting, and image distortion. To address this, a meticulous on-site calibration process has been developed.
This is the second group that goes into the lens, and this consists of one anamorphic element. And this is the third group, and that consists of two anamorphic elements that are combined in this group.
A special window is opened on the side of the lens barrel. The lens groups are initially secured with spring screws, allowing for subsequent adjustment. Technicians use tweezers or specialized tool to gently adjust the angles of the lens groups while observing the projected image. Once the clearest image is achieved, the spring screws are replaced with fixed screws to permanently lock the position.
So when you go all the way to the outside, you start to see chromatic aberration to creep in and the image to get a little bit blurry, which is actually characteristics that is very typical for anamorphic lenses and a desirable trait. But the further you go towards the center, the more the lens sharpens up for a very nice organic fall-off.
We ended this project with a wonderful evening at the Riviera in Shanghai. From their terrace, you're overlooking the skyline, and at sunset, it's a truly magical place. And for us, it offered a great moment of serenity. I want to thank the whole Laowa crew for supporting us before, during, and after our trip to China. I want to thank Dae-Young Lee for allowing us to do this documentary in his factories and for being a part of it himself, for his expertise, and that he's so willing to share all this with us and you. I also want to thank Mr. Lee for his generosity and for being so honest, kind, and nice to us. He really showed us Chinese hospitality. Very special thanks go out to Harper and Kiva from Laowa's Hong Kong division. It is almost impossible to pull something like this off without local support. Harper is part of the international distribution and marketing team. She was our producer, organizer, translator. She really was our link to the Chinese culture and way beyond. If you ever get to work with her, you are really lucky. Thank you, Harper. Kiva is Laowa's resident filmmaker, and he handled our technical needs, organized gear, the crew. He documented explanations and was generally a trove of good information behind the camera and beyond. When you see Morty and me in the frame, you can be sure that Kiva is flying the gimbal.
We don't know this guy, he's just been following us for the last hour.
Kiva also has eyes everywhere, like You guys can't see this, but he dodges. There are so many people around.
It's amazing. I mean, it's
I
like,
wouldn't have tripped and fallen like.
it is
times
a
now.
wonder that he didn't.
Thank you, Kiva. You are genuinely good at this. Thank you to Morty for joining this trip. It was a great experience as always. Through our many collaborations, you became a part of the media division. Don't forget to check out his brilliant filmmaking channel Morty Films, where he will release the detuning episode to tickle your DIY ambition. Last but not least, we want to thank the members of the media division that make complex productions like this possible. Your kindness and generosity allows independent filmmakers like us to produce the content that you are interested in, and we can't thank you enough for it. If you love our content, please consider to join the media division by becoming a member yourself. We have interesting perks for you. The join button is right next to the channel name below this video. If you are a manufacturer of gear or an industry hero with something exciting to share with our lovely community of professional filmmakers, let's talk. Our email is in the description. I'm Nicholas, signing out with Nerdlicious wishes. Shoot something amazing.